Hello and welcome to REGO-FIX Tech Chat. My name is David McHenry. I am the Engineering and Technical Manager here at REGO-FIX USA. One of the most common questions we get is, what is vibration damping? What is it? Where does it come from? And what's it doing in our manufacturing process? Well, let's spend a few moments and talk about that. In the manufacturing process, whether it's a small tool or a large tool, you have flutes, and the flutes are around your cutting tool. Each one of those flutes makes contact with the part during your machining process, creating an impact. That creates vibration. So what happens with that vibration? Well, depending on the tooling system that's being used, it's either passed through or it's damped. So what's that mean? What is vibration dampening? What's it look like, and where does it come from? So to show that, we have a little example. So I have a little fiberglass rod, and we're going to pretend this is your cutting tool. So this will be an undamped system. So I'm going to take this, I'm going to hang it over the edge of my table that you can see here, and I'm just going to flip the end of it, and this represents the machining process. All your flutes making contact with the part and the vibration that it creates. So you can see a very excited system, and it takes quite a while for that to stop. Well, if I have vibration damping, I have a way to absorb that vibration. I can change that vibration from going back into my system, and I just remove it from the process. So I'm going to take a little piece of clay, and I'm going to set it on the edge of the table and put my rod back over the edge. Now when I flip it, you can see how fast the system comes to a stop. That's because this little piece of clay is acting as a vibration damper. It's absorbing all that vibration. So how's that relevant to our industry and machining practices? Well, like I mentioned, every time your cutting tool passes the part, it sends a shock wave or vibration back into your tool holding system or into the part you're manufacturing. If it's back into the part you're manufacturing, well, you're going to see that as chatter and noise on your finished part or in your shop when you go out and listen. If it's going back into the tool holder, well, it can also show up as chatter, but it can also show up as spindle wear and damage to your bearings. So you really want to make sure you take care of that. But how do we dampen it? What's the mechanism for doing that? In the past, and as is most common in most shops today, collets are being used, like an ER collet. Collets are basically springs, and the spring allows it to absorb the vibration very, very well. But collets aren't what you normally see in the high performance industry. You see items like our powRgrip tooling system, you see items like shrink fit and hydraulic chucks, and other tool holders along those lines with high clamping force and minimum TIR. One of your options for high performance tooling that has a high quality of vibration damping is the powRgrip tool holding system. So we're going to bring a little graphic up, and we're going to show you why the powRgrip system has high vibration dampening as an option for you in your machine shop. The powRgrip system is composed of three parts: the cutting tool that you supply, the collet that's being used to hold onto it, and the tool holder itself. Each one of those parts is made of a different material. Vibrations don't like to cross material boundaries. So as that vibration travels through my cutting tool and wants to transfer into my collet, well, it's damped. The vibration frequency is cut. The same thing happens from the outside of my collet to the inside of my tool holder. It's damped again. So two broken surfaces between the collet and tool holder and between the collet and cutting tool dampen those vibrations significantly. On top of that, I have two different stresses involved in the process. I have a collet that is under compression because it's been pressed into the powRgrip system, and I have a tool holder body that is in tension as it's been stretched out. Just like the broken surfaces, Vibration does not like to cross stress barriers. So each one of these stresses also adds to the vibration dampening of the system. Well, that's two methods, but there's actually a third. All the materials being used are different. You have a cutting tool made out of carbide, ceramic, or high-speed steel, or cobalt, or you name the topic or tool you're using. You have a collet made out of one type of tool steel, and you have a tool holder made out of a different type. Just like broken surfaces and stress values, vibration doesn't like to transfer readily from one material type to another. Every time it has to transfer, it is dampened. So, 3 different modes of damping the vibration gives powRgrip an unbelievable advantage. In today's market, you can find tool holders with built-in damping systems, whether it be like our XL holder with a micro friction dampening system built into it, or tool holders with heavy metal rods, all designed to absorb that vibration and keep it from going back into your spindle or into your part. It's up to you to determine which type of system is best for your application. Thank you for watching our REGO-FIX Tech Chat. My name is David McHenry.